Hi, everybody. Today I'm going to show you a trick on how to memorize radians. I'm going to show you this before we actually get to our notes for today. Now, if you remember the radians in quadrant one, filling in the rest of the quadrant should be pretty easy. So in quadrant one, we have pi over 6, pi over 4, and then pi over 3. So 6, 4, 3. Now in the next quadrant, we're going to have the same denominators, but check out what they do. So we go 6, 4, 3, and then 3, 4, 6. And I'm going to go ahead and put my little fractions in all of these other quadrants as well. So we go 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Okay. If you can remember that pattern, what I'm about to show you is pretty easy. Now, I have to give credit where credit's due. Whenever I was learning the unit circle at one point, many moons ago, I recognized that pattern. I was like, oh, the denominators, they go 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. But I didn't pick up on this pattern. So over here in quadrant 2, you can take your denominators and subtract 1. And then make sure you give those numerators pi. Now over here in quadrant 3, you can take your denominators and add 1. Just remember, give the numerator a pi. And then over in quadrant 4, here's what you can do. You can take the denominator, multiply by 2, subtract 1. So 3 times 2 is 6. Subtract 1 is 5. 4 times 2 is 8. Subtract 1 to get 7. 6 times 2 is 12. Subtract 1 to get 11. And now for the most part, you have the most difficult portion of radians done. You just need to remember this one. And then if I take my pen and go around the unit circle and stop here, I've done pi radians. So now I'm going to backtrack a little bit. Well, if here to here is pi radians, then here to here must be half pi radians, or pi over 2. So here to here is pi. We're zooming back here. Here to here must be 1.5 pi, or 3 pi over 2. And then if we go all the way around the unit circle, we have completed 2 pi radians. Hopefully that'll help you memorize the radian portion of the unit circle. 1. Okay, unit 3, day 5 notes. Previously on X-Men, we have been solving for angles or radians, or more specifically, particular values of radians or degrees of the unit circle. So let's see how much we remember from previous classes. I'll give you a little cheat sheet there in case you need it. If I were to ask you, what is, I don't know, how about let's go with sine of 210 degrees. Do you know what your answer would be? Now, we're not looking for radians, we're looking for the value. It's going to be an answer right in here. Okay, 1/2, that's a very good answer. Is that the correct answer? It's negative 1/2. Yes, so kudos, you're on the right track. It's negative 1/2. Reminder, here's how we do this stuff. So if they want to know what is sine of 200 degrees, we'll first locate where 210 degrees is. What you then have to do is figure out, well, in order to solve this, are we using the 30 degree, 45 degree, or 60 degree family? And here's how you can tell. You need to look at the angle that you're trying to solve for, and then compare the distance between the angle and the closest x-axis. In this case, that's 30 degrees. Here's 180. 180 plus 30 is 210. So we're going to be using the 30 degree family. I asked you, what is sine of 210 degrees? There's the sine value of the 30 degree family. And now we must remember, all students take calculus. The only thing that's positive in quadrant 3 is tangent. Therefore, our final answer is negative 1/2. Now, here's where today, what we're doing today is a little bit different. Why is finding sine of 75 difficult? Don't be shy.
Because it's that time, so it's gonna like go all the way around.
Okay. I like that answer. Anything else? It's not one of the reference angles. There you go. It's not on the unit circle. So what they have provided us, they provided us some wonderful formulas or identities, whatever, to help us solve that. So that's what we'll start doing. Looking at example 1. This is non-calculator. Great question. Yeah, reminder, this entire test is non-calculator. All right, so for example 1, if we're going to find sine of 75, what we have to think of is which quadrant angles can we add together or subtract together to get 75 degrees? Any guesses?
45 and 30.
45 and 30. Now you just said 45 and 30, right? 45 and 30. I'm going to do this. Sine of 30 plus 45. It doesn't matter though if I had written 45 plus 30. I just like writing it from least to greatest, but it doesn't matter. You could have put sine of 45 plus 30. Now, warning, this is not your final answer. You wouldn't just simply go, oh, I just need to find the sine of 30 value and add that to the sine of 45. No, you don't. We have to now find which formula are we going to use. So here's how you do it. This starts with the trig function sine. So we're going to look in our formulas over here and figure out which of those trig formulas also begins with the word sine. That would be option 3 and 4. Agreed? Okay. Now we had to add 30 and 45 together. So now I'm going to look in parentheses. Which of those is A plus B? Well, it would be formula number 3. So that's the formula that we're going to use. I'm going to go ahead and write that down. Why did I say that weird? Down now. A B plus sine of B. All right, now we know what formula we're going to use. What I'm going to do, I think this helps, is we're going to set up group A. We're going to set up group B. And I'm going to write myself a little note here that for group A, we are using the 30-degree reference angles. And for group B, we are using the 45-degree values. If you need the cheat sheet, here it is. So if you'll notice in your formula, they are using sine, they're using cosine. So I need to find the sine and cosine values of 30 degrees. If you don't remember what they are, here they are. We only need the sine and cosine. And it matters what order you write them in. Reminder, as an ordered pair, you start with your cosine value first. Cosine, sine. Group B, the values for 45 degrees sine and cosine are here. So 2 over 2, root 2 over 2, cosine, sine. And now what we do is we simply start plugging in. So what I need is I need the sine value of group A first, which is 1/2. Multiply that with the cosine value in group B, root 2 over 2. And then plus the cosine value in group A, which is root 3 over 2, times the sine value of group B. And now we begin simplifying from left to right. I'm going to do 1 times root 2 over 2 times 2 plus root 3 times root 2 over 2 times 2. Now remember, whenever you're adding or subtracting fractions, you have to have a common denominator, which we do. Whenever we add or subtract, that denominator is not going to change. We just need to simplify the numerators by adding them together. And just a reminder, it's been a while since we've added or subtracted roots. you can't add radicals or subtract them unless they have the exact same number inside the root. So your final answer is going to look like that. And for the most part today on your notes, on your assignment, that's what your final answer is probably going to look like, something like that. Okay. Okay. Let's move on to example 2. Sine of 285 degrees. Yeah, you're good. Now, if you happen to be in person today, lucky you, if you'll look to the very top right of that board there, you'll see where 285 degrees falls in the coordinate plane or the unit circle, somewhere around there. So one strategy that you want to implement when you're doing these things is have an idea of where the angle is in the unit circle that you're trying to solve for, and then get an idea of what the reference angles surrounding the angle that we're trying to solve for look like. So if we're trying to solve for 285 degrees, we want to know what are the reference angles around 285 degrees. Okay. So what we're now going to do is, given those reference angles around 285 degrees, we're going to figure out which of those numbers can we either add or subtract to our reference angles in quadrant 1 to get 285 degrees. Any ideas on what that could be? So you see how I have 3 angles written down in quadrant 3? Right? Those are some reference angles in quadrant 3. Which of those 3 angles can we either add or subtract to reference angles in quadrant 1 that will get 285? Yes.
240 and 45 degrees.
240 and 45 degrees. Perfect. Are there any others? Are there?
25 and 60.
225 and 60. 315 and 30. Would you need to subtract? Yes. Here's what I'm trying to get at. There could be multiple combinations. It doesn't matter which one you go with, as long as you pick the right formula and you plug everything in correctly. Doesn't matter. I'm going to go with sine of 40, not 40, sorry, sine of 45, and add that to 240. I'm then going to label these A plus B. If you'll notice, this is going to follow the exact same formula that we did for example 1. Still using the sine value. We're still adding reference angles together. So let me create group A, create group B. Now for group A, we are going to be using the 45-degree family. I'll make a note for myself here. It doesn't matter. No, it doesn't matter which one's A or B. Okay, for group B, 240 degrees, what reference angle family are we going to use? 60. Yeah, we're going to use 60. And if you don't remember why, it's because 240 degrees is 60 units of measure from the closest x-axis. So we have to use a 60-degree family. All right. For the 45-degree family, your cosine and sine are root 2 over 2. Root 2 over 2. Cosine. Sine. For the 60-degree family, those values are 1/2 and root 3 over 2. Cosine, sine. But wait, 240 degrees is here. Yes, we're using the 60-degree family, but we're getting that because we need help with the 240-degree angle. If 240 degrees is in quadrant 3, what's the only thing that's positive in quadrant 3? Tangent. So what's going to happen to my cosine and sine?
Negative.
They're both negative. Boom. Good. And now we can take our given information, plug it into the exact same formula that we did earlier, and simplify. I would like for you to try and do that on your own now, please. I will work on it myself silently in case you get lost and need help. That would be your final answer. When you're done, look up, see how you did. Does it matter if in your numerator it was -6 or -√6 minus √2? No, doesn't matter. That was example number 2. Yeah? That was, okay, let's go to 3. Now for example 3, here's what I want you to do before we begin working on that one. Look at example 4. So for example 4, what they want us to solve for is cosine of 26 pi over 24, right? But here's what they did. They were so kind. They told us exactly what reference angles to use that would add to get 26 pi over 4. They did not do that on example 3. You will not have to find that on your own if it's written in radians on your next test. So what I'm going to do is I'm going to go ahead and give you what these radians are, just like they did here. And if at the end of the notes, you're like, how did you do that? How would you get that? Let me know and I'll come over and I'll show you. Okay. So for example 3, it is sine of pi over 3 minus pi over 4. Now here we're using the sine formula again. Just notice this time we're subtracting, so our formula is going to change just a little bit. I would like for you to try and work on this one on your own, please. Give it a shot. Get as far as you can. If you're just 100% lost, I'll start working on it myself. What do you think?
I would just negative. Why is it for sine of pi over 3 minus pi over 4? Why is it not plus like this?
Because in this particular situation, we would have to use reference angles and subtract them from one another to get what it was. They wanted us to find sine of pi over 12, right? Okay, so reference angle pi over 3 minus pi over 4, that would get you pi over 12. Yes, no? Does that make sense? Okay, example 4. Once again, notice that they have given you exactly which reference angles they want you to use. This is how it will be on your next test. If it's in radians, if it's in degrees, you're going to have to do like we did. You know, you're going to have to figure out what we figured out in examples 1 and examples 2 first. All right, so for 4, we are doing this time cosine of pi over 4 plus 5 pi over 6. Here we have A plus B. Notice this time it starts with the word cosine. So we're either going to be using formula 1 or formula 2. They are adding these two fractions together, so we will be using the addition identity. So we're using formula number 1. Please note that in cosines, even though, yes, this is the addition identity, there's a minus sign in the equation. That's okay. All right, so we are going to be using formula number 1, which is cosine of A. Cosine of B minus sine of A. Sine of B. So in our group A, we'll be using pi over 4 values, which will be root 2 over 2, root 2 over 2. Over in group B, now look at what they've given us, 5 pi over 6. Do you know what the reference angle of 5 pi over 6 is?
150.
Okay, it's 150 degrees, you're right. So do we need to use the 30-degree family, 45-degree family, or 60-degree family?
30.
30, what is that in radians? Pi over 6, yeah. I think finding your reference angles in radians is easier because whatever the denominator is, 6, then we're going to use the pi over 6 family. I think radians is a little bit easier to find the reference angles. All right, for the pi over 6 family, that would be root 3 over 2 and 1/2. Please note, 5 pi over 6 is here. All students take calculus. The only thing positive in quadrant 2 is sine, therefore our cosine value must be negative. And now we can start plugging these values into the formula and see what we get. Y'all start working on it. I will as well. Yay! Good job, y'all. Okay, we're gonna go ahead. What's the question? Never mind, no. Okay. Go ahead.
Plus between the negative square root 6 over 4 plus negative square root 2 over 4 equals, what is the sign?
It's supposed to be a minus.
Here.
Okay, that's minus.
Yep,
Okay, thank you.
thank you for the question and for pointing that out. Thank you. All right, let's move on to example 5. We will not be doing example 6 because I think you'll find that these are actually pretty easy. Okay, tangent of 75. Now we already found the reference angles of 75 whenever we did problem number 1. That was 30 and 45. Group A. Group B, notice that this begins with the word tangent. So we're either going to be using formula 5 or 6. Which one do you think it is? 5. It is. We're going to be using example 5. Now, here's what I would like for you to do. Just take a moment and look at the formula itself. Just the formula. Look at it. I only see the word tan in that formula. Do you? So we don't need to worry about cosine or sine this time. We just need tangent values. So in group A, I need the 30-degree tangent value. In group B, I need the 45-degree tangent value. Tangency of 30 degrees is root 3/3, and tangency of 45 degrees is 1. Now here's what I want you to do. I want you to take these values, plug them into the formula, and then wait. Start plugging in, please. Okay, did we all substitute correctly? Here's why I think these are the easiest ones. Well, we only have to find the tangent amount. And then once you get to this point where you've plugged everything in, for the most part, we're done. We really can't simplify anything in the numerator over. The one thing that we want to simplify in the denominator is root 3/3 times 1, which is just root 3/3. Now here's why these are easy. We are going to accept that as the answer. We're not going to make you rationalize the denominator here. Once you get to that far, you're done. Okay. All right, let's look at example 7. I think you'll find that these are pretty easy. So what we're doing is we're working backwards now. I'm going to try and break this down as easy as I possibly can without getting too mathy on you. You see how this begins with the word cosine? I'm going to write the word cosine and then parentheses. Now, since this starts with the trig of cosine, I'm now going to go up to my formulas and identify which ones begin with cosine. Well, that's formula 1 or formula 2. I'm now going to go back down to example 7. I'm going to take note of that symbol right there. That's a subtraction symbol, right? So I'm going to go back to these formulas up here and figure out which one of them has a subtraction symbol right in the middle. That would be example 1. Now I'm going to move over here. You see those parentheses? This is the addition property of cosine. So what we now have to do is look at 25 and 20, the numbers it's given us, and add them together to get 45. Now, is 45 a reference angle? Yeah, so we can find cosine of 45. That is root 2/2. That's your answer for 7. Give example 8 a try on your own, please. Okay, I'll start working through this one. Example 8. This begins with the trig function sine. Sine parentheses. I'm now going to go up to my formulas and figure out which formulas begin with the word sine. That would be 3 and 4. I'm now going to go back to example 8 and take note of that symbol right there. It's subtraction. I'm going to go back to my formulas and see which one of those formulas also has subtraction right in the middle. That one there. I'm now going to go to parentheses. This is the subtraction property. So all you have to do is take 45 and 15, subtract them to get 30. 30 degrees is a reference angle, and sine of 30 degrees is, anybody? 1/2. That's your answer for example 8.